Okay, so what we note above is that this equation is non-linear. So it is noted that the equation is non-linear, and it is non-linear. Why? Because due to the interaction term, due to the interactions. So there are interactions now, and because of this, it is non-linear. This is in contrast to Schrödinger equation. Yeah. So this is basically important to note here. Um, we have used the representation V of V, where the matrix elements of the V operator as being diagonal. And usually, जो eigenstates हैं, they are position states. Then this can be reduced in a more simplified form, this Heisenberg equation of motion, by sort of considering that there is some symmetry. Yeah. So if if we use representation where V is diagonal, V is diagonal. Uh, Normally, the states are in position space. So normally, eigenstates of position, that is diagonal, then this reduces to this reduces by considering first this this with with this representation that JQ of VSR equals to V JQ delta JS and delta QR. And we also know that V JQ बराबर होता है व्यू क्यू जे. सो जो हमारी इक्वेशन है ऊपर, दैट इज आयोटा एच बार डी ए जे अपॉन डी टी, that reduces to summation over L J H naught L A L plus summation over Q B Q dagger, or rather A Q dagger, A Q dagger, A Q A J to V J Q. So this is in fact mm, a more simplified term. Now we can represent the same equation of motion, the Heisenberg equation of motion, in coordinate representation using the field operator. So in coordinate representation using the field operators, हमारे पास इक्वेशन क्या बन जाएगी? आयोटा एच पर डी बाय डी टी साई सिग्मा of r comma t, which is equals to summation over sigma prime integral d3 r prime. Then we have this r sigma of H naught and R prime sigma prime psi of R prime, or rather function of time as well. R prime comma T, yeah, plus the terms plus sigma prime integral d3 prime interaction term v of r comma r prime psi sigma prime dagger of r prime t psi of sigma prime of r prime t psi of sigma of r comma t, yeah? And basically ये जो आपके पास टर्म है, in fact this term, this is basically the V effective potential, uh, that is the effective potential. और यहाँ पर V of R and R prime, it's basically a two body interaction, yeah, where V of R prime and R and R prime, R prime is a usual two body interaction. Yeah. Basically, जो equation है, it shows that how the field operator at one point, let's say R, depends on the field at all other points. So that is basically the utility of field description rather than quantum mechanical description. So in some sense, the equation above shows how the how uh, how the field operators at one point, let's say R, depends on the field at all other points, at all other points. And what does this mean? This implies uh, that it includes the effect of interaction, the effect of many particle interaction. अच्छा, एक चीज का ख्याल रखना है कि यहाँ पर साई ऑफ, बिकॉज हमने कहा ये फील्ड ऑपरेटर्स हैं, साई सबस्क्रिप्ट सिग्मा, सो दीज आर फील्ड ऑपरेटर्स, दे आर नॉट वेव फंक्शन. It is basically a field operator for a quantized field. Yeah. So very important note जो यहाँ पर आपने सोचना है, that psi sigma of r comma R comma T is not not a wave function. Rather ये क्या चीज है? It is a field operator for a quantized field. For a for a quantized field, which is very important because ये हम coordinate representation दे रहे हैं field operators की है, so it has to be remembered. And so this is the starting point of field theory. So once you have identified that they are not wave functions, but they are basically operators and rather field operators, and so this becomes as the starting point for the operator. Uh, when H naught depends on coordinate and conjugate momenta, then this quantity would become then the Hamiltonian when when H naught in the equation depends in the equation of motion depends on coordinates and conjugate momenta. Then we have this sigma, sorry, R sigma of H naught R prime sigma prime would become H naught, which is a function of R minus iota H into del. This would be R minus R prime and delta sigma and sigma prime. And then the equation is similar to the Schrödinger equation. Then the equation is similar to Schrödinger equation. And how is that? It becomes iota h bar d by dt. And then we have psi sigma of r comma t. Remember, this is an operator rather than the wave function. It's not a wave function. H naught of r minus iota del. H naught is a function of this quantity. Psi, this psi sigma of r comma t plus v effective जो ऊपर हमने डिफाइन किया हुआ है, which is a function of r and t times sigma of r comma t. Okay. So v effective depends upon psi sigma itself. It is and obviously this is again an indication that the equation is non-linear. Not the above this equation, that is this equation for multi-particle system where interaction is involved, is exhibiting some sort of a non-linear behavior, that is the interaction of particles with each other. Yeah. So one could say, however, v effective depends depends on psi sigma, that is operator itself. Then this implies it is a non-linear term exhibiting interactions. Interactions of the particle with other particles, with each other. Therefore, finally, we need to write a corresponding equation for the multi-particle wave function. So, uh, at the end, the corresponding equation for the multi-particle wave function. तो क्या हो जाएगा? dt. Then we have this operator, and we have r1 sigma 1, r2 sigma 2, and so on up till rn sigma n, and this is equals to summation over j equals to 1 to n h naught of rj comma minus iota h bar del j, which is the kinetic energy term, plus half summation j is not equals to L V of Rj comma RL, Rj comma RL. This is bracket close. Psi of operator R1 sigma 1 comma R2 sigma 2, so on up till Rn sigma n t. Yeah. And this exhibits the distinction between the field operator psi sigma and the multi-particle wave function. So obviously the number of arguments are different from psi sigma, which is basically a field operator, whereas here this psi is in fact a wave function. So which exhibits the distinction between the फील्ड ऑपरेटर जिसको हम यूं लिखते हैं साई सिग्मा या सबस्क्रिप्ट सिग्मा ऑफ आर कॉमा टी and the multi-particle wave function. And why is that? This is because they have different number of arguments. Number of arguments. So basically, this completes your many body systems and their interactions, starting from identical particle, and then we went all the way to interactions or then multi-particle system, many body systems interaction. So हमारे पास equations of motion भी आ गए, operators भी आ गए, field distribution भी आ गए, field operators भी आ गए, and so on. Next,